everyone. You're looking at a live view of the SpaceX Starship V3, Ship 39, and Booster 19 atop Pad 2. These cameras that you are seeing are from NASA Spaceflight. I have their channel linked in the description. They are also doing their own independent stream if you want to check that out. So, this is the second launch attempt. The first launch attempt yesterday was scrubbed ultimately due to a hydraulic pin on the ship quick disconnect arm. It's the little arm poking out about halfway to the top of the tower connecting to the ship. There was a hydraulic pin that failed to retract. Now this pin is there to prevent it from swaying. During fueling of the ship, but it needs to be released so that the arm can swing all the way back so it isn't destroyed by the 33 Raptor engines. So we're really hoping for a great launch today. Yesterday at the start we were 55% go on weather. Today we are 85, so already looking much better. It's a 2-hour launch window today. Window will open up at 4:30 p.m. Mountain Time, 5:30 p.m. Central Time, and it will close at 6:30 p.m. Mountain Time and 7:30 p.m. Central Time. So the main show will begin at T-minus 1 hour and 5 minutes. I will be providing periodic updates when things start to happen, but I have a lot of cool things lined up. Getting into just under an hour, the SpaceX stream will start at T-minus 90 minutes, so we'll definitely tune in for that. It's very exciting. First flight of version 3. It's gonna be a great time, so I will see you guys when I have more updates for you. Just a little update. The final tanker trucks carrying cryogenic liquid oxygen and cryogenic liquid methane, along with cryogenic liquid nitrogen, have all left. They're no longer coming in. SpaceX personnel are no longer letting trucks in. So this is a very great sign because this means that the tank farm is fully filled with cryogenics, ready to fuel this vehicle. So just want to let you guys know. I'll come back to you with more updates when they become available. You can just see one of the final tankers leaving. There's looks like about three left. Might be two more hiding behind, but 3 to 5 left. They're getting very close to flight here. Okay, so every single truck that is used for loading up the tank farm has now left. The pad isn't fully cleared yet, but we're still over 2 hours and 30 minutes until flight, which is totally normal. But the loading area for the tank farm is clear, other than that sheriff vehicle and a Cybertruck. So the tank farm is fully filled, and it is ready to take the biggest and most powerful launch vehicle, really vehicle in general, ever made. So this is getting very exciting. And we're getting close to launch. Also, if there, if I thought, if vapors like that touch you, that is a sign that you should not be there at that time because the beach is probably closed. Now, if the water deluges, if they do get deluged, that's fine. Actually, I'll take it. There's the things. Yeah,
like half done work. We all want to do one more thing, and if
Hey,
we have
Membies,
another
is this
hour,
stream
we could try
looking
to
and
put out
sounding
another
better
camera.
today?
If we have another 30 minutes,
I
we could
made
try
some
to like
changes
wipe
last
another
night.
lens or something like that. I don't know. Let's get another microphone out. So, what's that? The thing from the Fantastic Beasts, right? That fills all of the available space. We do that with time getting ready for flights. We people around me are chuckling. You know what I'm talking about?
Better
We
today?
fill all the time that we
Working.
actually have
Hey,
because we
Carson
always
Craig,
need
that's
one
what
more
this
video.
stream is
One
for.
more.
Alright, so I have an amazing update for you guys. If I may direct your attention to the bottom right of your screen, you will see venting from the tower. This is in the area of the SQD arm, and this is a very good sign. This is the purging of the lines with liquid nitrogen. Now, the reason why they do this is because if you set all these propellants, the liquid oxygen, the liquid methane, it's cryogenic, which means it used to be a gas, but it's been cooled so low, it's in the negative 200 degrees Celsius range, and it becomes a liquid. So if you just start running that through tanks that are like Texas air temperature, you could crack them, break them, just cause all sorts of damage. So you slowly start to flow liquid nitrogen through the lines, and it brings them down to that temperature so that when you start pumping in all of those propellants, it won't crack the lines, damage them, just damage any equipment. This is also why they cool down the Raptor engines, or really any rocket engine that takes cryogenic propellants for that matter. Because you actually, before you start a rocket engine, if it takes cryogenic fuels, you don't actually prepare it for the heat. You actually prepare it for the cold, for the same reason why they're purging the lines here. Now, the Raptor purge or the Raptor chill will happen a lot later in the countdown, around the T minus 2 minute mark. It will happen on both the ship and the booster, but also the Raptors will be chilled down on the ship well in flight before stage separation. But you can see the tank farm getting more and more active. The liquid oxygen and liquid methane subcoolers really starting to power up, cooling down the massive amounts of propellants. It's over 5,000 tons, metric tons for that matter, of propellants alone. So it is an extreme amount of propellants and a lot to cool down. They're actually starting the cooling process a lot earlier today than they did yesterday. Most likely just to verify everything and make sure that it works, because once again, new ship, new booster, new pad, heavily upgraded tank farm. A very, very valid argument could be made that this is the most important flight of the Starship program thus far, and I would agree with that. We're coming in on a new age of spaceflight, and one of the rockets that will be spearheading that age is going to be the SpaceX Starship, and today is another major milestone in that journey to returning humans back to the moon, bringing people to Mars, and going beyond. So very exciting times. So I'll come back to you with more updates when they become available. Yeah? That's good. Yeah? Okay. I can't help but notice there's rules right now.
Oh, sorry, I was on. I wanted to just go to the market now so that I can jump back on.
Oh, okay, did you catch the latest update? It's really good.
Oh, I don't know that.
Oh.
Oh, is it 1:58? And you're gonna start broadcasting again at 1:05?
Yeah, well, I'm still broadcasting. Like, I'm giving periodic
Sorry.
updates.
Yeah.
This is kind of like the main show. I have a bunch of stuff lined up that I want to talk about, and it should take us like maybe two minutes, 30 minutes for the space extra. So,
So what time should I like really make sure that I'm on it?
I'm really sure. I mean, like, absolutely before T minus 1 hour 5 minutes.
Okay. Okay, I'll just have it. I'll put my earbuds and then I
Do you
can
think Debbie G is watching?
message her. You know, did Nono tell you he was watching yesterday?
Oh, yeah, he did. Yeah, he texted me after.
Okay.
That's awesome.
Okay, I'm gonna have my earbuds in and then I'll your brother track.
Okay, could you guys do it? Thank you. Love you. Oh, yeah, well. Oh, Mom! Thanks for the drink. I completely forgot steak. They're probably 4 fucking screens. On the members multi-game, absolutely. I gotta pull that up. Yeah? Let's check. Yeah, I'll let her out if she wants to come out. Okay, love you. Bye. You can see the live comms like there. said Sean.
Makes good sense. All right. So the clock is continuing to count. We got
Come on, we gotta be faster, man.
flyovers.
Damn.
Flights, and we are now less than 2 hours away from the opening of the window. I want to remind everybody, it's a window. There's a little bit of time to work with today. I just heard
I'm sure it was like a playful joke.
Alex has something he wants to tell us. It's the confuse the media situation here with
Coming to you, Dots for Merch Plug.
they started to do something else.
Just telling Das.
Your life.
Anyways, folks, hey, really quickly.
I'm just telling him.
Mentioned it earlier in the show. More and more people show up. We are able to do this because y'all keep showing up and supporting us. It's not like we're all independently wealthy and we just get to go and spend our parents' money or anything like this. We have some people who do this full time, myself included. We have some people who are doing this as a part-time job. They come out here for events to help us out. There's folks who volunteer.
Oh shit. Yo, this. I gotta get a Flight 12 patch, bro. It looks so good. Maybe a Flight 12 shirt. Either way, I just want to get some food. And show if it's okay. What if they have a timeline, like, you know, saying like, hey, at this time we're gonna talk about the patches. Or do you think it's maybe about at this T-minus we're gonna talk about the patches? Okay, it sounds fucking stressful. Bro, it sounds stressful. Being one of the guys, it's just like, I must say, these comms are elite. Brother. Oh no, he's listening to what he's saying. Like what Das is saying. Oh no, right, he was asked to click on that line shirt. That's normal. Yeah, obviously, I'm kind of a one-man show here. Yeah, I'm solo and I'm out with a gigantic team. Oh yeah. Yeah, I agree. I was definitely thinking that as well.
Excuse me, this is a post on X by
Let's go, Area. Alright, so the tower vent has returned. It stopped for a bit. That wasn't expected, but thankfully it's back. Now you can see that helicopter leaving. Since this is a private spaceport, there's actually not a government agency running security on the range. So it's SpaceX in conjunction with, occasionally working with other agencies, but it's mainly just private security services. So that there's that helicopter going. Hopefully that's just completed its last refueling stop. It's not just that helicopter. There's about probably around 3 other helicopters and around 2 aircraft. They're used to pull security on the range. But yeah, everything's looking great. Tower vent's back. You can see some venting getting in front of the bottom right camera on NASA space flights. Starbase 24/7 cameras, so we're getting very close to launch. Around looking just under an hour 24 out. So hopefully we'll have a great launch today. And yeah, a lot of cool things lined up starting at T-minus 1 hour and 5 minutes, so I'll see you guys there. All right, everyone, we are back. We're going to sort of transition into a more info giving method instead of a live update method. I was still give updates, but right now I want to talk about the actual Starship Flight 12 flight. How is it going to fly? Where is it going to fly? And just kind of the sequence of events that we are expecting from today's flight. So this obviously isn't the entire countdown. This countdown's actually starting at T minus 50 minutes. But at T minus 50 minutes, we'll have the flight director conducting a poll for a go no go poll for loading of propellant. So they'll be checking, the status of both the ship and booster, the status of the tower, pad, tank farm, weather, range. Just make sure that everything is ready to go because you are like once you begin loading fuel, you are committed to a much smaller kind of window in your current launch window. So continuing on at T minus 30 yeah, T minus 38 minutes and 53 seconds. The ship will begin loading liquid oxygen, that cryogenic liquid oxygen. It will flow from the tank farm up the tower through that ship quick disconnect arm and onto the bottommost tank on the ship. It'll be very apparent when it starts loading. You'll be able to see a line of white. You won't be able to see it if you're looking from the side of the heat shield, but if you're looking from the side of the actual stainless steel, uh, it will be extremely apparent. It'll be a just it'll be a white line that slowly creeps up and now on the booster at T minus 35 minutes, we will have the booster liquid oxygen loading. Now that's once again, it is the bottommost tank. It's the same on the ship and the booster. The bottom tank is the liquid oxygen, and the top tank is liquid methane. However, in the ship, there is a header tank, which is used, it's the fuel for the landing bird. And on the header tanks, there's two tanks, one for liquid oxygen, one for liquid methane. The liquid methane one's actually below the liquid oxygen. Though when loading of ship liquid oxygen begins, the loading of the liquid oxygen header tank will begin, and the same for liquid methane on the ship. Now at T minus 21 minutes and 30 seconds, we will begin the cooling down of the Raptor engines. This involves flowing a small amount of propellant through the pipes, but not igniting them, not starting up the turbo pumps or pre-burners, just letting the propellant flow slowly through. And so you might be able to see like some propellant like dripping from super heavy or dripping from the ship. So if you see that, it's totally normal. um you can very much tell when the ship is performing its Raptor chill because there is a vent just beside the leftmost aft flap. It points straight down, and if you see venting and like a white gas cloud coming out of that, that's an indication that the Raptors on the ship are currently being chilled down. Now, also in flight, the ship's Raptors will get chilled down once again, just before stage separation when it needs to ignite those engines. And now jumping all the way down to 2 minutes and 50 seconds, booster propellant load will be complete, and 40 seconds later, it will be ship propellant load complete. Other than SpaceX officially confirming that the prop load is complete, you'll be able to see that tower vent that you would have seen just before, probably around like 20 minutes ago. That tower vent will come back, and it will get extremely strong all the way up to pretty much just before launch. And no, obviously these aren't the only things in the countdown timeline. These are just the things that SpaceX actively says, such as in the case at around T minus 20 seconds, around 30 to 40 seconds. They don't show it here, but that the hydraulic pin is supposed to come out of that ship quick disconnect arm. It didn't release yesterday, which caused the scrub. But we're really hoping that'll actually release this time, and we'll have a launch today. Now, continuing on, we will have at T minus 30 seconds, the SpaceX flight director will verify that all systems are go for launch, as well at this time, the ship, the ship and booster, as well as the towers, flight computers will take control of the countdown. So it will no longer be humans saying you're cleared for this procedure. It will be the vehicle and pad working together. Obviously, it'll still respect a if a person commands a hold, but it isn't a person like giving clearance for launch, giving clearance for engine startup, or for flame diverter activation. This is all the vehicle and pad doing it, working in unison together. Speaking of the flame diverter activation, at T minus 17 seconds, we will see the bottom flame trench start spewing water out of it. One moment. Okay, it looks like the roadblock is about to clear momentarily. So we'll watch that, and I'll pull that up when it begins clearing. But continuing on, the flame trench, the two holes that you see just below the launch mount, that is the flame trench. You can't see it right here, but it almost hits a point in the center, then dips down, and then the curve slightly up on the edges. And that, well, diverts the flames. It will protect the launch mount from the 33 Raptor engines, and this was selected after the old OLM when it was just concrete legs taking the power of 33 Raptor engines, which was very bad for reusability, required extremely heavy refurbishment, and was overall for the objectives that SpaceX wanted to achieve with Starship, that pad just wasn't going to cut it. Now at T minus 3 seconds, the booster will send the command to start up the Raptor engines. Now, since the video is actually kind of delayed from the telemetry on the SpaceX stream by about 3 seconds, it will look like the engine start up at T0, but I assure you it starts up at T minus 3 seconds. Once again, it will look like the Starship launches at T plus 3 seconds, but it actually will launch at T minus 0/T plus 0. And that will be a very exciting launch. Now, if we look at the trajectories, oh boy. So, before you launch a rocket, you need to get a bunch of things in order. A lot of it is. A lot of this is closures. Now, on ascent, rockets always fly over water. So, the two things that you mainly need to secure is the air and the water. So, if you look on your side here, all of the ones in like red/orange, these are for air. So, NOTAM is a acronym. It stands for Notice to Air Missions. And it's just essentially saying it's on every single aircraft throughout North America and Europe. Almost on every single aircraft in the world, they have a system that will detect a NOTAM or TFR, temporary flight restriction, and it's just essentially a place just like where you're not allowed to fly. So in this case, you can see it actually will, the NOTAM actually spreads out slightly and then curves back in. Where it curves back in, that's about where the stage separation is, and the booster is only going to stay in this almost shallot-looking area. Now, as it slowly thins down, that's the ship's ascent path, and where it stops right here. And when it stops right here, that is where we will have Seco. A moment. It looks like SpaceX has confirmed that the launch director is go for prop load. So this is, we're great. Go for prop load in about in about 24 minutes, or no, in about 12 minutes we should see ship LOX loading begin. And we are getting very close. We're about 20 minutes away from the SpaceX stream starting, and we'll absolutely join when that happens. Now moving on to the ship entry and area. If you look, you actually see kind of hooks, almost. And what this is this is going to look a lot like the trajectory that ships will take when they're coming in to land back at the launch site. Oh no, I'm sorry, it looks like there's just some issues with the stream. Um, sec. Okay. I'm sorry, just a bit technical difficulties. Okay, so looking back at the ship trajectory, you see that it slightly hooks, and that is there. Oh, okay. That'll actually mimic when Starship returns to the launch site for a tower catch. It'll need to fly over populated areas, which is usually not allowed. They'll get special clearances to do so. But over the really main big populated areas such as Brownsville, yeah, so like flying around Brownsville or the large cities in northern Mexico, they wouldn't be allowed to do that. So this trajectory would take them around those areas that they aren't going to fly over. And if you look at this hook, they'll actually be coming the opposite direction from where the tower is facing. So, to actually be caught by the tower, you can't just go straight into it, or else you'll hit the back of the tower, you won't get caught by the chopsticks. So it'll actually perform a 180-degree turn. This will be very apparent on the SpaceX stream. You'll hear the call out, ship is on final approach. Now, obviously not to a tower, but it's a simulated final approach to the target point. So the ship will it'll yaw almost a full 90 degrees using its lifting body design. Almost as a space shuttle would, or just a regular airplane. Now if we look more at the air clearances, or I'm sorry, sea clearances. Okay. If you look at the blue areas, you can see these are the not Mars, or notice to mariners. Now, these are essentially just telling boats the same thing that it tells airplanes. Just don't go here. Right now, it's not just rocket launches that there could be not Mars for VIP transport. Just it just essentially just says don't be here. There's these activities happening. Along with this compass in black, it actually extends a lot farther than the Notmar. This actually applies to both air and sea, and it it says the same thing as both of them. Don't come here, but it's meant so that you can navigate it even if your navigation systems fail. That's why it's called compass, because you can navigate it just using a compass. With a Notmar, TFR, NOTAM, or nav warning, you would need a navigation system that has GPS. But if you didn't have access to GPS at the time for whatever reason, you could use a compass and you would still know that this area you cannot enter. Now, I just wanted to take you guys back to the it's mainstream, because the tank farm is getting a lot more active. Um, in preparations for tanking, that's going to be in just under 10 minutes from now. So we should see the SpaceX stream start up in about 17 minutes. Now, another thing I want to cover is we know the trajectory. Now let's talk about what's actually going to be happening on this trajectory. So, this is the just kind of. Oh gosh. Okay. So at T plus 45 seconds, this is substantially different from other rockets. Starship version 2, slash version 1, it it reached max Q at T plus 1 minute and 5 seconds. So this is a full 20 seconds faster to get to max Q. That shows like that even in slow motion, this this rocket's gonna come off the pad so fast. So it's really cool how you can like almost tell performance of rockets just by looking at the timeline. Such as it reaches Seco and at 8 minutes and 11 seconds. On version 2, it reached it at 8 minutes 30 seconds. That's 19 seconds faster. It's like I was saying, even even in slow motion, you'll see this rocket is going to come off so fast. It's going to come off the pad faster than New Glenn, even though it's just even though it's slow motion. And I believe that they're not even going to run it at the highest throttle setting, because this is the first version of a rocket in history that can lift 100 tons to low Earth orbit. So it needs an extreme amount of power. So at T plus 2 minutes and 22 seconds, we will have super heavy MECO, or most engines cut off. Followed very shortly 2 seconds later, that by hot staging, where the Starship Raptor engines will ignite. It will be in a staggered pattern to help nudge the booster in the optimal rotation direction for boost back burn. And we also expect that the super heavy restart of its Raptor engines will as well be in a staggered manner to further assist with the rotation into the optimal trajectory for the boost back burn. So at about 1 minute later, we'll have super heavy boost back burn shut down. Now, if it was coming back to the launch pad, it would probably go about 10 to 15 seconds longer. But since it's going to land just off the coast, its trajectory is not going to make it all the way back to Starbase. Now, It will then rotate over, vent off propellants, and use those three grid fins, one for yaw and two for roll and pitch, to orientate itself using its lifting body design to guide it towards its launch site. Or, I'm sorry, its landing site. So the landing burn will start up at T plus 6 minutes and 34 seconds around. Now, obviously, this may actually slightly vary because at the end of the day, it's the onboard flight computers that are making the decision. Hey, this is when we will ignite the Raptor engines. But it should be around T plus 6 minutes and 34 seconds. And it will then, it will light up 13 of its gimbling Raptor engines, then down select to 5, and then go down to 3. Now, going back to the Starship, at T plus 6 minutes and, or I'm sorry, 8 minutes and 11 seconds, we'll have Starship Engine Cutoff or SECO, and then followed by the payload deploy demo start at T plus 17 minutes and 37 seconds. Instead of carrying 6 Starlink satellites like on previous flights, it will carry 22 Starlink simulators, 2 of which, the last 2 to be specific, will have cameras on them that will be used to inspect the heat shield. Now, if you look at the Starship's heat shield, a few on the perimeter are actually painted white. They're still the regular black heat tiles, but just with a white coating over them. And this will just help the cameras on those satellites track exactly where the heat shield is and then observe the heat shield while looking for any possibly misaligned tiles, cracked tiles, or just fully missing tiles. There is one intentionally removed tile around the nose section, and that is used to it's going to be used to observe the how the airflow changes on the adjacent tiles. So at so about 10 minutes later, we will have payload deploy demo complete, and then followed by that about 11 minutes later, there will be the in-space Raptor Relay demo. This will be of a single gimbaling Raptor 3 engine. Now further on, we will have Starship entry interface at T plus 47 minutes and 47 seconds. And at around 85 kilometers, the flaps, you can see the 4 flaps on the Starship upper stage will take control of the vehicle, guiding it through hypersonic reentry. As the external temperatures hit around 2,500 degrees Celsius. It will also perform a intentional stress test of the aft flaps, almost pitching the vehicle over in a very aggressive manner to just test and stress out the flaps intentionally. Once again, technically the payload is Starlink simulators, but at the end of the day, the payload is data. They are pushing this vehicle farther than it would ever be expected to in a regular low Earth orbit mission. They are putting it through more extreme forces, demanding more out of the engines, putting it through higher heating, intentionally removing tiles, all in the name of just finding the limits of the vehicle, finding out where does it break, and you launch these test flights too. You don't expect it to go absolutely perfectly. This isn't a NASA mission where they spend 20 years before the first flight. It's build it, launch it, see where it breaks, then iterate from there. And it creates extremely, extremely, extremely reliable vehicles. So now, at T plus 1 hour, 2 minutes, and 29 seconds, Starship will become transonic. This will probably be mid hook maneuver as it's entering that simulated final approach. And just about 30 seconds later, we will have Starship being fully subsonic, and at T plus 1 hour, 5 minutes, and 6 seconds, the landing burn will start. Now, this will involve the ship actually first being completely, it will almost be parallel with the water surface. Like, 90 degrees off, how do you expect? It won't be coming down straight down, it'll actually be in a belly flop. And when this landing burn starts, it'll ignite the engines, rotate the aft flaps in, fully extend the forward flaps, and flip the vehicle over. Now, it won't just go straight. It won't just go to point straight down. It'll actually slightly overcorrect to remove the horizontal velocity induced by the igniting of the engines when it's parallel with the ground. But due to the higher thrust to weight ratio of the engines, you actually need to shut down engines to prevent the ship from just going back up again. So, at T plus 1 hour, 5 minutes, and 17 seconds, the landing burn will go from 3 engines to 2 engines. And at T plus 1 hour, 5 minutes, and 24 seconds, it will down select just to a single Raptor engine. And at T plus 1 hour, 5 minutes, and 26 seconds, we will have a very exciting landing, marking the end of Starship's 12th flight test. Now, since we talked about the trajectory that's flying, now let's talk about the vehicle that's flying it. Starting off is Pad 2. This pad does so much, it's actually usually known as Stage 0. Now, if you look, you can see the flame trench and the two booster quick disconnects. Now, that is a very big change on this new pad because it's not just a single BQD, it's actually two. One for liquid oxygen, one for methane. This allows for higher flow rates of both propellants and also increased safety because you don't have two propellants that, if they're mixed, they can become extremely volatile, sitting in gaseous form, mixed with each other. Also, you can see there is a flame trench. All this pad design is fully made with the thought of rapid reusability. You can see it has, it has a brand new flame trench. It will have a water-cooled top deck that you will be able to see it fire up at liftoff. One moment. Okay, yeah. So I just got tripped up. I had to check something. Okay, now continuing on, the Starship full stack standing at 100. One moment. Standing at 124 meters tall. This will be the biggest and most powerful rocket ever made, breaking its own record. It will still be 9 meters in diameter, but with obviously an added extra 2 meters. And this is the first version of Starship that has a payload capacity of over 100 tons to low Earth orbit. Now, looking more at the Starship itself, it is the same height and width as its version 2 counterpart, 52 meters tall and 9 meters wide, but it has substantially more upgrades. On each of the flaps, instead of having two actuators per flap, it only has one now, but with three motors for extra redundancy. This improves reliability, reduces mass, and just overall increases the performance of the vehicle. It carries actually slightly more propellant because, yeah, so it will be carrying slightly more propellant, to be specific, 1,600 tons. That's up from the 1,500 tons of version 2. The reason being is that they extended the tanks down and lifted the engines up so that the power heads are actually slightly inside the fuel tanks. Also, they got more space because of the Raptor 3's design. It allows so that it doesn't need fire suppression, meaning that they could get rid of the aft of a just empty aft section, which meant that they had more space to place more fuel. Now, it has added thrust due to the brand new Raptor 3s at 1,614 tons of thrust, and obviously with a payload capacity if it's paired with the Super Heavy of over 100 tons. Now, talking about the Super Heavy, this has the most amount of changes. Obviously, the first thing that you notice is the integrated hot stage ring. It almost looks as if it's a Soyuz rocket hot staging ring or an N1 hot staging ring. This is back from This is now integrated, so it is not separated during flights, and it is a substantial upgrade, substantially lighter, and stronger than on version 2. Now, the version 2 hot stage ring was just a temporary solution before this booster came. No longer, Super Heavy no longer has a 4 grid fins. It now only has 3, 1 for yacht and 2 for roll and pitch. The ones for roll and pitch actually now have catch points on them. It used to be separate lifting and catch points from the grid fins, but now they've been integrated on to the grid fin. The grid fins are also 50% larger, and the yaw grid fin, the one that's just sitting on its own, is actually pitched slightly up to prevent it from pitching the entire booster up during its glide down. Now, once again, upgraded with the Raptor 3 engines, Super Heavy now produces 8,240 tons of thrust and added propellant capacity due to it not having to have that attic section, same reason with the ship. So it has, as well with it being 2 meters taller, it has 3,650 tons of propellant capacity, up from about 3,400 tons. As well, you can see the chines are substantially longer from version 2. The chines closest to the raceway are now longer and closer together, and the ones farther apart are shorter and farther. The ones opposite to the raceway are shorter and farther apart. Also, Super Heavy now carries about twice the amount of COPVs, carrying all the commodities required for It carries gaseous methane and liquid oxygen for Raptor spin up and ignition. It carries nitrogen for the operation of pneumatic valves, and SpaceX has confirmed it, but possibly helium. So, moving on to the Raptor sea level engine. It is one of the biggest redesigns across the entire vehicle. Due to its simplification, it no longer needs to have its own fire suppression system, because if it does spring a leak, it just goes into the stream. As well, it's up from 230 tons of thrust to 250. It still stays the same size, and it actually has a slightly higher, or it has around the same ISP as its version 2 counterpart. Now, if you actually take into account all of the shielding that's no longer required and all of the fire suppression system and commodities that are no longer required, you actually save around 1 metric ton per engine across the vehicle with Raptor 3. Now, with 39 currently on the vehicle and 42 on version 2, that is 39 tons of weight saving, which means 39 tons more that you can send to Earth orbit, as well as beyond. Okay, so now we are going to switch over to the SpaceX stream. But first, we have a hype video to play, so let's get ready to go.
Beckons while I dream. Now there's ease. Stand upon that, woven by a single thread. Fall down upon you.
flight directors go for launch. Flight director.
Of Quality Systems Engineering. Of Quality Systems Engineering.
And I'm Jake Berkowitz, a lead propulsion engineer. And today we're coming to you live once again from just outside the production floor at Star Factory, where the team's preparing for Starship's 12th test flight.
Yeah, yesterday was certainly a nail biter as we recycled to the T minus 40 second hold a couple of times. And while we unfortunately weren't able to lift off, keep in mind that this is the first flight of a completely redesigned vehicle. So we actually learned a lot in what became a wet dress rehearsal yesterday.
Yeah, that's right. And Starship version 3 has undergone significant upgrades, taking everything we've learned from the previous 11 flights to make a vehicle capable of full and rapid reusability.
We're debuting a new launch pad, new booster, new ship, and new engines, just to name a few.
Yeah, that's right. And as a member of the Raptor team, I can tell you we're all super excited to finally see the newest generation of Raptor engines, also V3, take flight today.
I love that view looking up under the Super Heavy. Now, Raptor and Starship version 3 are designed to enable us to send payloads and eventually people all the way to the moon and Mars.
Yeah, and in the meantime, we're planning to put Starship to work on future flights by launching bigger and more powerful Starlink version 3 satellites, which aim to substantially increase capacity in orbit, strengthen the network, and deliver an improved experience for customers.
Now, turning our attention back to today, our primary objective for Flight 12 is to put these new redesigns all together in a real live flight environment.
Yeah, it's also muted.
From the outside, a lot might look familiar on Starship, but beneath the surface, it's all new. As we've said before, Starship is still a developmental program. What we're doing today is a test. We launch to learn, and we test like we fly.
Yeah, and it's really the data we're expecting to get back from today's flight that will bring us closer to making Starship operational and unlocking the next generation of our future in space. So, no matter the outcome of today's test flight, excitement is guaranteed.
Now let's head a couple floors upstairs where Dan Hewitt is just outside our Launch Control Center. How's it going up there today, Dan?
It's going great, Kate. Everybody, welcome back for round 2. I'm Dan Hewitt with SpaceX Communications. We're looking good for a launch today. Do you want to do a quick summary, though, of what we saw yesterday, how we got back to launch? It's a really good example of all of the different moving parts that have to work together to get a rocket off the pad. About halfway up that tower, you see an arm that holds all of the propellant connections into the ship. It's also set up so it kind of pushes against the ship to help make sure that we have a really good connection, and it stays attached when we unlatch that quick disconnect. There's a pin in the arm near where that attaches to the tower that has to be removed before the arm can swing away for launch. It's important to remember there's a lot of benefit to not release the arm too early or too late, and a lot of hardware that has to work in concert in very, very short time frames. We started to unpin it, releasing that tension caused a motion in the arm that triggered a hold, and that put the pin back in. Then that ended up got
So Oh, come on.
Raptor engines are going to be igniting directly into the top of the booster. That's where you're looking right now. All of that force and heat offset by the pressure inside the booster's fuel tank and a thin layer of
See, Raptor
non-structural
Chill is
steel.
very much
The grid fins on the
underway
booster, which we used to steer on
on both the
descent,
ship
went
and
from
booster.
4 down to 3, but we made them 50% larger. Higher strength, also use them for lift, and we'll use them for catch on future missions when we bring the booster back. We redesigned the fuel transfer tube inside the booster. That's what's sending all of that massive amount of liquid methane down to those 33 engines, lets us light all 33 at the same time and have faster, more reliable flips. The bottom of the booster looks very different with those Raptor 3 engines. We deleted all of the bulky engine shrouds from previous generations, all of the prop, avionics hardware, everything for that super tightly integrated now, protected by much slimmer shielding. Up on the second stage, Starship version 3 designed to carry massive orbital payloads up to 100 metric tons to Earth orbit, the Moon, and Mars. Biggest changes inside the vehicle itself. Propulsion system got a complete redesign, increased our propellant tank volume, improved our steering on orbit. In the payload bay, the PEZ dispenser is supercharged. That's going to increase the deploy speed for each of our satellites. We've got 22 payload deployables in there today. It's the heaviest we've ever carried on Starship. Eventually, we'll have up to 60 planned of those Starlink V3 satellites. Also on the ship, we added docking ports. There's 2 right below the payload bay door, 2 near the bottom. That's going to enable us to have starships link up in orbit for propellant transfer. Also modified the connection point in the ship to facilitate that. So a lot of upgrades tip to tail, and still powering it all is the Raptor 3. Now, those engines are manufactured in Hawthorne, California, tested in McGregor, Texas, redesigned their ignition system, bumped up the thrust in the sea level and the vacuum engines, and then took all of the sensors, feed lines, controllers, everything that was kind of the busy sections around Raptors 1 and 2, and either deleted them or internally integrated and protected them inside the engine. That dramatically cut down on the weight, made it easier for those to manufacture. So, just an incredible amount of effort from the world's best engineering team getting this rocket to the pad, ready to launch today. I'm going to stop talking for a little bit. That was a lot. Send it back down to Kate and Jake for more on Pad 2.
Yeah, so like Dan was just saying, the team has been working hard on a brand new rocket, but we also redesigned the ground systems. And that brand new Pad 2 is making its debut today.
We took everything we learned from operating on Pad 1 to create this totally new launch pad. Pad 2 is optimized for full and rapid reusability. We've upgraded our propellant farm with much more storage and more pumps to enable super fast filling for launch and relaunch. And on the tower, we changed to shorter chopsticks. That's the black assembly there at the top of the tower, and that enables even faster motion to better track vehicles flying in for catch.
Yeah, and we also changed the actuators driving those chopsticks from hydraulics to 100% electromechanical, increasing their speed, redundancy, and reliability. On the ground, the launch mount was also completely redesigned, and if I had to describe it in one word, I'd say robust. But it's also smarter. We've separated the fuel and aux systems into different compartments and repositioned the booster quick disconnects to be out of the vehicle's plume during liftoff.
And as you can see there on your screen, we also have a new bi-directional flame diverter and a new top deck flame deflector to eliminate metal wearing down. So we said goodbye to the pancake. However, this will help us get to 0 refurbishment between launches. Now, this pad is still built for maximum safety and fast turnaround because making life multiplanetary will require
Oh no.
Quist, and I'm a Starlink
but
business
look how you can
analyst
see
here
the
at SpaceX. We're
different
excited to be
Raptor
back here in
versions behind
Hawthorne,
them.
ready for
You know, 1,
another
2,
attempt
3.
at a launch today. So as we talked about yesterday, on today's flight, we're deploying 20 Starlink simulators, plus 2 modified Starlink satellites, which our team internally refers to as Dodger Dogs, because they stretch the V2 mini satellite propellant tank so that it sticks out from both ends of the satellite. And the Dodger Dog serves as a tech demo between the V2 and the V3 Starlink satellites, and acts as a platform for testing V3 components. Now, the larger V3 satellites aim to greatly expand our network's capacity, while V3 hardware is designed to support faster Wi-Fi and improved broadband speeds for our customers while providing significant capacity upgrades from the V2 Mini. So, in addition to delivering future V3 satellites to the Starlink network, Starship is also planned to launch our AI satellites. And as you may have seen during the TerraFab event in Austin a few months ago, Elon laid out the path to revolutionize cloud computing and AI infrastructure, leveraging the unlimited power of the sun, targeting 100 gigawatts to 1 terawatt of AI computing power annually. And from there, we're looking at connectivity beyond our planet too. Building on the technologies used to connect people on Earth, the Starlink team is exploring using Starlink to enable high bandwidth connectivity around the moon. With a constellation of satellites designed to connect to user terminals on the lunar surface, we could relay data back to our Starlink constellation in Earth orbit. So traditionally, deep space comms have relied on radio frequency transmission. But this new design would use lasers to relay data back to Earth, which can massively increase the bandwidth available to future lunar missions. We currently have thousands of lasers operating in our Starlink constellation around Earth, and deploying that technology around the moon could connect it with hundreds of terabits of capacity. Together, this could provide the connectivity backbone between the Earth and the moon, and enable gigabit connectivity anywhere on the lunar surface, providing data for rovers, habitats, and astronauts, and hopefully some incredible views for us back on Earth too. So all of that adds up to a lot of satellites, but the good news is there's still plenty of space in space. That said, the Starlink team takes space safety extremely seriously and works hard to encourage best practices across the entire industry so space stays open for as many people as possible. In fact, just yesterday, the Starlink team published a new update on Starlink.com to encourage all satellite operators to better coordinate and follow best practices to keep space safe. So for more on safety, go to starlink.com/updates. And with that, let's kick it back over to Kate and Jake and Starbase for today's mission profile.
Thanks, Tyler. Now let's dive into the flight profile for today's test. As we've mentioned already a couple of times, there are numerous redesigns making their debut today across the entire launch vehicle. In light of this, we want to keep our learning focused on all of that new hardware and software. So we're running a flight profile that's similar to past Starship flights in order to minimize any new variables.
Yeah, that's right. So as always, we start with liftoff, where Super Heavy ignites 33 of those brand new Raptor 3 engines. We power through ascent ahead of hot stage separation, where the booster shuts down all but 5 sustainer engines. Stage 2 then lights its Raptor engines while still attached to Super Heavy, where we see stage separation, debuting the integrated hot stage, directional booster flip, and engine relight for boost back using 33 engines. And after coasting for a few minutes, the booster today will target a landing burn and soft splashdown a few miles off from the coast of Starbase.
Ship keeps it going with ascent burn to a suborbital trajectory. Then we'll deploy 20 Starlink simulator satellites and 2 Dodger Dogs, as we affectionately call them. We also plan to relight a single Raptor engine. Next will be re-entry a few minutes later. For the first time in a while, we're intentionally not messing with Starship's heat shield. At that point, we should have some amazing views of the ship's Technicolor re-entry through Earth's atmosphere. If all of that goes as planned, we'll finish the test with a landing flip, a landing burn, and a soft water splashdown in the Indian Ocean. And in just a few moments, thanks to Starlink, we'll be going live to the Indian Ocean and chatting once again with the ship recovery team stationed out there.
Yeah, I'm super excited about that. That's going to be totally awesome. But sit tight because first we're going to go to Dan for a quick status check.
Yep. Hey, everybody. Good news. Still looking good. Range is green currently. We're expecting another update on that in just about 4 minutes. That should be our final determination. Weather continues to look amazing. Vehicle and pad both looking healthy. We are a little over 80% on fuel, 95 on LOX in the ship, and then a little more than 2/3 it's looking like on booster. So we are on track today, looking good for a launch right now at 5:30 p.m. Central Time. All right, so we're going to do that right at the top of our window. Once again, though, we're going to be targeting to send Starship around the world for a splashdown in the Indian Ocean. We had a really quick check-in yesterday with the Starship recovery team out there on station. They're helping us to maintain the range and a whole lot more. So let's jump back out there once more today. We've got Suren Sunai joining us live from the boat deck out in the Indian Ocean, a couple hundred miles off the coast of Australia. Suren, how's it going, man? Welcome to the Flight 12 webcast. How's everything looking out there in the landing zone?
Dan, it's a pleasure to be here. I'm not going to lie to you, it's a little rougher than it was yesterday. Nighttime, it's hard to see the horizon, but we're looking at about 10-foot seas, and we're loving it, but it's rough.
All right, what's
as you mentioned, like it's usually a 500 to 600 nautical mile sail from shore and make sure there's no one else in the area so the rocket can launch. But that kind of allows us to do our second goal, which is to conduct imagery of the rocket as it re-enters and as it splashes down. We get a lot of other data, but like the primary one is for sure imagery with an ensemble of maritime and aerial-based assets.
And talk to us a little bit, because it's evolved over time, kind of humble beginnings of getting those views, to talk us through where we've gotten to now today.
Yeah, I think some people know, but like the Markset bots are quite identifiable. That's the buoys that we use, and they were originally used as sailboat racers, and we kind of put them in as a Hail Mary attempt on Flight 5 to get imagery of the rocket as it came down. And we all thought it maybe would have worked, but we were super shocked and really pleased to see all of the buoys pointed right at the rocket as it came down, which was a testament to not only the scrappy engineering we were able to put together, but also the rocket's ability to land right on target. And then since then, we've kind of iterated more and more, and these buoys have become way more robust and have now a lot more data collection materials, not just visual imagery. And as a result, they kind of are the most mature versions they've ever been. And it's really cool because almost all the buoys that we're deploying even now for Flight 12, we just got them off our back deck a few hours ago, are the exact same ones that were used for Flight 5.
And I saw a couple of user terminals. How's Starlink kind of playing a role in this entire operation?
Dan, I'm not gonna lie to you. If we didn't have Starlink out here, we would be screwed. Like just on like a usual basis of like working, we're allowed to like have calls with each other and like work on documents with each other, send things to each other in like a very timely manner because of the Starlink on the boat. But not only that, each one of these buoys is equipped with a standard Starlink Mini, the one you would just get from like ordering it commercially, and that allows us to not only operate the buoy remotely, but also to get live stream data and telemetry, which is honestly super useful, and I don't think we have another solution for it without Starlink.
All right, before I let you go, what's it like? You're out there and then all of a sudden Starship appears out of the sky. What's that feel like, man?
Dan, I can't lie to you, it feels awesome. Just like being on the boat, not seeing any land for miles and miles, and then hearing the Starship crack down with its sonic booms and watching it breach through the sky, it is one of the most magical feelings on Earth, and really excited to feel that again today.
All right, well, thanks, Suren. Good luck, man. Hopefully we're sending the rocket your way real soon. Thanks for joining us in, man. I'm going to send it now back down to Kate and Jake for the latest progress we're making at Cape Canaveral in Florida.
Thanks, Dan. Now, if we want to get to the moon and then Mars as fast as possible, there's really only one answer, and it's to launch a lot more rockets.
Yeah, and to do that, we're going to need a few more launch pads and support buildings, which is exactly what we're working on over in Florida. So originally built for Apollo and then the Space Shuttle, Launch Complex 39A has flown 126 Falcon missions since SpaceX reactivated the pad in 2017.
Yeah, I actually remember the day that we did that. I was able to host the live webcast for that first launch out of Pad 39A, and it was just so amazing to see that pad come back to life. And it's also exciting to see how today, almost 10 years later, the ongoing construction, as you see there on your screen, and the development that will bring a second launch tower to Launch Complex 39A. It's designed to expand our capabilities to support Starship launches in the future, while also continuing to support Falcon Heavy missions from the original Apollo Shuttle Falcon launch tower.
Yeah, and we're not done. We're also building a Starship launch pad at Slick 37. And to support the uptick in future launches,
Gigabay?
there's Gigabay, a giant assembly and maintenance facility designed to prep Starships ahead of Florida launches. And when complete, this huge structure aims to hold 24 work cells in over 800,000 square feet of workspace. It's going to be a big building.
So much space.
So yeah, SpaceX's future in Florida is quickly taking shape with our very first launches on the horizon.
Exactly. A horizon that aims for regular trips to the moon. And speaking of moon, we've got another special guest for you today. Dan, I think the last time you and I were on a webcast with this person was Polaris Dawn, as he was performing the very first commercial spacewalk.
That's right,
Sure,
Kate and Jared. I don't know if today will be quite as cool as doing a spacewalk, but we're going to try our best to make it as exciting.
Oh, wow.
Like, thanks for joining us here today, man. You had a heck of an entrance on the way in.
It's great to be here. Yep, certainly great to do a little bit of a flyby. I think they should accompany all the great rocket launches, and we certainly got a great rocket out there on the pad. But wonderful to be back, and no surprise, it's always changing here. It looks amazing.
I was going to say, it's been a couple of years. What was your impression flying in? It just the lay of the land.
Well, I think it was actually maybe 10 months ago. I was here slinging pizzas.
administrator.
I got a new job now, but it was. There's been so much that's changed even since then. The facilities look amazing. All the housing that's coming in here, and of course, you got 2 orbital launch pads out there and a rocket that's just looking fantastic, especially from the air. It's good.
Yeah, you said you got a new job. It's been a slow start to your first 6 months. I mean, you only sent humans around the moon for the first time since the Apollo days. Thing I worked on when I was at NASA, so seeing them go was just insane. Like, how's everybody feeling after the success of Artemis 2?
Well, I'd say I have the best job in the world, and I certainly work with. That mission was a long time in the making, so I got to show up at the right time to see everybody put all that effort to put it in action. But what a great mission! Those 4 astronauts, you couldn't have had better ambassadors for humankind to the stars. I mean, they really brought us all along for 10 days, and we're getting ready for what comes next. We're going to start stacking Artemis 3. We got a lot of the hardware in the VAB already. We're hoping to even get out to the pad before the end of the year, do another wet dress. So,
all right,
and we're looking forward to seeing this thing fly, because hopefully at some
along
point in the not too distant
extremely
future, we're
fast
gonna join up in Earth orbit.
Yeah, what's coming up next, and ultimately, like, based on the moon, that's the big focus. Like, what's kind of the why? Like, why are we doing this for everybody?
Oh, well, I mean, and yes, we're certainly trying to get back to the moon, but what's coming up next? We're also building a moon base in parallel. And why are we doing that? Well, it's for a lot of the shirts I see around here, which is Occupy Mars. I mean, what a great opportunity. Go to the moon, return to the moon, build a moon base on the South Pole, interact with the water ice, right? Maybe work on some of those skills we're going to need when we're 4 days away from home for what we might need someday when we're 9 months away from home. But we got other things coming up too. You got Nancy Grace Roman, that telescope's going to launch later this summer. There's a lot of great, exciting things going on at NASA right now.
Yeah, man. All right. Well, SpaceX, we're custom built to try and make life multiplanetary. We're super honored, excited to be part of this entire Artemis program. Really excited to see Starship, sending people to the moon, all of the different pieces working together. It's going to be a really exciting future.
Oh, absolutely. Well, thanks for having me here. It's great to see everybody. Again, I know a lot of hard work leads up to a moment like this, so we're all rooting for you, and we're looking forward to meeting up next year in Earth orbit.
All right, man. Well, I'll let you jump back in there. We got about 4 minutes to go. I'll toss it back down to Kate and Jake.
Yeah, I think it's safe to say we could listen to you guys yap about the moon pretty much all day. It's so inspiring to hear about the future of exploration on the moon. And if you caught the show yesterday, you also heard some more future space exploration news.
Yeah, that's right. From 2 Mission Commander Chun Wang will be one of the first humans to become an interplanetary traveler. Don't think I've ever said that word before. While also joining Starship's first mission to fly past the moon. Incredible.
Amazing. In fact, that Dragon capsule that you saw there was Dragon Resilience. That is the same Dragon spacecraft that Administrator Isaacman flew in both Inspiration 4 and Polaris Dawn. So it's a good one. Now, Dan, we're now coming back into a terminal count again. Anticipation is definitely growing as we proceed towards our second attempt. Once again, this is the first flight. We're aiming to fly for the first time Starship version 3, massive upgrades across the vehicle that you see at the pad there, as well as the pad itself.
T-minus 3 minutes and 30 seconds.
The good news is we've had a pretty quiet countdown today. We are looking at a green range still, not tracking any issues with our weather, with the vehicle, or with the pad for a launch. We are now getting into the phase where we're closing out prop load on the ship, and then booster is going to close out in about 15 seconds or so. Once we're fully done with this, you're looking at 11.5 million plus pounds of liquid propellant on board Starship and Super Heavy. We're going to get the pad itself ready, push back all of the propellant that's in those lines running from the farm up to the launch mount, just kind of harden the area and get it ready for launch. We're going to peek inside, hopefully see the engines do a little wiggle as we do our final steering check. That'll happen at T-minus 100 seconds.
In quick succession. That is when the QD vent gate, or quick disconnect vent gate, will clear the gas commodity lines that connect the pad to the vehicles. Both the ship and the booster will configure their comm systems for flight and will rapidly run leak checks on gas and fluid tanks. And the booster goes to internal power and its engines will get their final priming for launch, while the ship's engines begin their assembly profile and arms the automatic flight safety system.
Yeah, and once we pass T-minus 40 seconds, we still have the ability to rapidly recycle the count under certain conditions back to T-minus 40 seconds.
Looks like we might be getting some engine wiggles here, as Dan mentioned earlier.
TVC test, though.
These allow us to check out the thrust vector control actuators on these engines. It's important to make sure that they can steer.
Yeah, that's definitely right. And flame diverter on pad 2 activates at around T-minus 17 seconds and enters what is essentially the point of no return at T-minus 10 seconds. If we have a hold close to T-minus 17 seconds, there's a chance we could recycle, but the closer we get to T-minus 10, the lower that chance becomes. We just heard we're at T-minus 1 minute.
Yeah, so at this point in time, we're going to stop talking. We're going to let the rocket take over and listen to some amazing pad sounds of the first flight of Starship version 3.
All right, we are holding. We were
Oh, okay, so it's totally good. All right, and we're continuing through the counts. Magic words from today's flight director. And getting ready. In 3 seconds, we'll have water deluge. The water deluge. You can see water deluge coming up. 10 seconds. 5. There's the top deck deluge. Ignition of the 33 Raptor engines. All 33. And liftoff of the first V3 Starship and the first flight from Pad 2. And vehicle is pitching downrange. You can see this. You can see the shock waves coming off from this, the biggest and most powerful rocket to ever fly, breaking its own record set in. And call out that the chamber pressures are nominal on the 33 Raptor engines on the Super Heavy booster. You can see the vehicle is rolling over and continuing ascent, just passed through 3 kilometers, 40 seconds into flight. Max Q. And it broke. Okay.
passing through the period of maximum dynamic pressure.
T plus 1 minute.
A little over a minute into flight now. Vibrations chilling out here
healthy Raptor
at Star
engines.
Factory as we continue to watch Starship Flight 12 arc out over the Gulf. The next major thing coming up is going to be hot staging.
Getting ready for hot staging.
Like you just reminder, we do what's our version of MECO. Most engines cut off, so we're going to shut down all but 5 of the Raptor engines on the booster.
T plus 1 minute and 30
then
seconds.
after that happens, we're going to ignite the 6 engines on ship while it is still attached. We have clamps that hold the 2 together. Those are going to retract inside of that
and
hot
25
stage ring,
kilometers in altitude.
kind of protect them. Looks like we had one of the engines go out, still flying on 32.
Looks like we lost the Raptor engine.
Once we get the hot staging, those
with the amount of
6
engines
on the ship
Starship,
are going to ignite.
Up to 3 on Super
We're
Heavy.
going to do it in a little bit
there
different
might be more.
of a sequence on version 3. Essentially, those 3 RVAC engines will ignite first. Almost immediately after, just one of those central engines is going to ignite.
Of the Earth now.
And that's going to give the booster a bit of a kick, sending it in a known direction.
We're getting ready for
shortly
MECO
after
here. It'll go down to
the
5
other 2.
Raptor engines. And here's booster engine cutoff. You can see those 5 Raptor engines, those 5 sustainers.
We're through MECO.
And then there's ship engine startup. And get ready for stage separation for the first time. For the first time, Starship V3 is flying free. We can see a staggered startup for the boost back burn.
Hot staging separation.
You can see 5 Raptor engines on the boost back burn as it guides itself back.
We're not seeing as many booster engines ignite as we expected for boost back.
It appears that we are not.
But we are seeing 6 good engines lit on ship.
All engines just cut off on the booster.
It looks like we just had an early boost back shutdown. Again, a reminder: the booster was planned to essentially head into the Gulf for a splashdown,
so that was not the
but
plan,
it has shut its engines down early
Raptors.
on into
we've
boost
lost an RVAC on the ship.
And we just see one of the RVACs, so
the booster
we're now running
rolling.
on 5 engines on
Once
ship.
again, this is a test flight. This is meant to see where things break, iterate, and
we do have engine out capability, so it's going to continue into its ascent.
There's still engine out capability on the ship.
You got booster on the left there, ship
Remember,
on the right.
Remember, these are test flights. You can okay, the booster's rolling over now.
Again, we are not planning on bringing the booster back for this flight, as this was the very first time. All right, so we're about 3 minutes, 50 seconds into today's flight.
It almost
just a reminder, the ship planned to burn its engines for about 8 minutes and change.
Looks almost it's performing
about 8 minutes and 11 seconds is our planned timeline for today. That could shift slightly as we do have one engine out running on 1 fewer RVACs.
Most likely, Seco will most likely be pushed back to slightly farther down. Possibly by about
continuing
5 to 10
to watch.
seconds.
So booster did not complete its boost back burn. We did not see all of the engines ignite that we expected.
You can see
are continuing to get some views from it though. That's going to make a splashdown somewhere in the Gulf.
Raptor 3s vehicle.
Reminder: we clear air, sea space, everything for these launches.
We might see if it will attempt. It will probably still attempt to perform the landing burn. We'll have to see how that goes, especially with the rolling as it gets into the thicker parts of the atmosphere.
All right, so we are coming up on T plus 5 minutes.
Stabilize the roll. T plus 5 minutes.
Ship continuing to fire 5 of the 6.
Appears that there's a slight flash of flame.
Standing by for callouts, making sure ship's on its planned trajectory. Again, we are planning a suborbital trajectory for the ship today.
9,000 kilometers an hour on the ship.
Booster giving us some views as it
ship on a nominal trajectory.
The water.
Booster coming down.
All right, so a little over 5.5 minutes in flight.
Trying
KJ,
to stabilize. Ooh, that booster is coming down. You can see the nozzles on the Raptors vibrating.
Got off the pad or the whole stack. That was quite incredible.
Absolutely. So we have views here from the booster coming back down.
It looks like it stabilized its roll, preparing for its landing.
Pretty cool to see.
Healthy chamber pressures on 5 out of 6 ship Raptor engines.
Okay, you can hear great chamber pressures on the. There's landing burn startup on the. Or I'm sorry, no, there's landing burn startup, and that's a fire.
Once again, we were not going to bring the super heavy booster back to the tower.
And it appears that we've lost
on having it land in the Gulf.
And it looks like the booster ended its mission there in the Gulf, but we've got a ship still flying.
But the
Great to see
ship
that.
is
Still have
still
5 out of 6
pushing.
engines there on S39.
Yes.
Once
we
again,
also
remember,
heard
these
good
are
chamber
test
pressures
flights.
as well on
They
those
found where
engines
it's
that are
right. They're
lit.
going to look at the
We
data.
do
and
have engine out
iterate
capability.
from
We
there.
do see that we have one
The
of
ship
the
is still
RVAC,
continuing
one
on.
of the Raptor
They have
vacuum
confirmed
engines
that
is
we're
currently
currently
out,
seeing
but
5
that's okay. Ship is
healthy
continuing on.
Raptor engines.
Amazing views of planet Earth
in T plus
there
7
in the
seconds.
background.
Once again, it'll probably Sequel will
Yeah, I
probably
love
be
the
shifted
S39
forward
decal
by,
there. That just gives the ship a little bit of character. And again, all these great views brought to you by Starlink, of course.
by about 5 to 10 seconds, just due to that RVAC not firing. It just has slightly less thrust
Obligatory
and
shout
thus
out to the entire Starship
needs a bit longer
avionics,
to gain that.
camera electronics team. Did a whole lot of work to get these upgraded cameras.
And you can see
A look
the
inside of the ship
It
skirt,
looks
you
like
can
that
see
the
those
Raptor
3
and
center engines
the
ignited,
RVAC that
the
was
RVAC
supposed to be there
continuing to
is
fire
no
as well.
longer there.
We did see at least a
No,
couple
I'm
engines
sorry, it is
fire up
there.
on booster
My
for that
apologies.
landing burn before we lost contact with it. We should have just a little over 20 seconds to go. We'll see if the burn extends a little bit. For
See
the
those
engine
tiles,
out,
just a
essentially you
beautiful,
can run your engines
beautiful
a little
looking
bit
heat
longer, or
shield.
throttle up a little bit more to account for the one.
I feel like it's important that we... Oh, I'm sorry. Stand by for Seco. Okay, this is the nominal Seco time. It's probably going to be extended just a bit. Okay, so T plus 10 seconds from Seco. Once again, just due to that RVAC that shutdown.
Five engines still burning on ship.
Still pushing. Okay, stand by. We should have Seco imminently. Just when the flight computer decides that this is the correct time and that they are on the correct trajectory, it will perform Seco.
We're coming up on T plus 9 minutes.
Crossing through T plus 9 minutes. So again, still waiting for Seco.
And starting to see shutdown.
There's shutdown of those 2 remaining RVACs, and
RVACs
stand
have
by
shut
for
down.
sea level,
Sea
and
levels
sea
have
level
shut
shutdown,
down.
Seco. Ship V3 has made Seco on its first attempt. Booster, unfortunately, did not make it, but I feel like the
Seeing
guidance
if we can get
navigation
an update
control team needs to be
on the
acknowledged
ship
there
orbit
of
insertion,
how,
but we have shut
as well
down
as the
again. We
camera
did run
teams and how
longer
the
as we were
camera
engine out.
feeds
We were
and
flying
telemetry
with
feeds
5 of
still
those
kept
6
on coming
Raptors
in
pretty
from the
much the whole
booster,
time.
and that it kind of regained control, unfortunately.
Ship FTS is saved.
And ship FTS is safe, confirming we are now in the coast phase. Successfully made it on the trajectory. I mean, wow. Another demonstration of the
All right,
resilience
well,
of the
we definitely got a
Starship
ship
vehicle.
in space right now.
Lost an RVAC on ascent, still made it. And we are in the coast phase. Holding attitude. Go to the Indian Ocean, but get ready. In about 7 minutes, we're going to see that aft flap
the
coming
teams are incredibly excited to see Starship there in space. We are awaiting the call out of nominal insertion, so we're going to stand by for that. We can see the flaps moving here, actuating. But wow, the cheers here in the lobby are certainly almost as loud as liftoff was.
Yeah. Man, a lot of action going on. And, you know, we said at the top of the show, excitement guaranteed. And we're only 11 minutes in. We still have a lot more to go here on the mission today. So all objectives are done on the booster. So now all eyes are on the ship as we get ready for our in-space objectives.
Exactly. So like I said, we're still standing by to hear the call out for nominal orbital insertion, but we've got a few minutes before the next milestone. So we're going to continue. We've got some amazing views here of the ship. Wow. It's just that this is our planet. This is our home.
That's Earth. That's home. Yeah, the Raptor teams are absolutely going to be analyzing the data that
As
they
a
got
reminder,
from
the
Super
objectives
Heavy
for ship today
on both the
not only
ascent and
included the
descent,
separation
and
that we
obviously
saw,
from ship.
but we're also planning to deploy 20 Starlink simulator satellites, as well as 2 Dodger Dog satellites. That's what our internal teams refer to as our newer satellites. We saw a preview of those earlier. We should see those deployments here in a little bit. We're also hoping to perform a relight of a Raptor engine as well.
Yep, that's exactly right. And the relight will look a little bit different this time. We're hoping to get a little bit of a longer duration. Of course, we got to see once we get there. And that relight won't actually be changing our orbit necessarily, but we're doing it more so as a technology demonstration.
You can see venting, just some pressurization regulation vents to just as the propellant warms up, it starts to boil off. Even in the coldness of space, it's still at this altitude, they're still over the boiling point.
For those of you
of
that
liquid
maybe
methane,
just
liquid
recently
oxygen.
tuned in, you missed a pretty exciting almost 13 minutes.
It was.
We had a liftoff pretty much on time, almost right exactly at 5:30 p.m. We did have a brief hold at the T-minus 40-second period, but we were able to proceed through that, and we saw a gorgeous liftoff. Jake and I were able to stand outside and witness that with all of our colleagues, and
kilometers.
what a moment. I'll tell you what, it is a heck of a lot louder out here than it was at Ad Astra.
Continuing on.
Absolutely. And a couple things I noticed on the way uphill today on the ship. So obviously it looks like we lost one of the RVACs on the way, but that is a good way to demonstrate our potential engine out capability there. So
exactly.
I think we actually saw the 3 gimbaling engines kind of gimbal over a little bit to compensate for that offset
Absolutely.
and thrust. So that was really cool. That's something I know the team's been, we've analyzed that since Flight 1 all the way back. So it's something that we've thought about quite a bit, and it was kind of cool to see it in action in real life today.
Yeah,
Obviously,
absolutely.
it's not ideal that
if you couldn't tell, Jake is on the Raptor team.
Yeah. But
well, he has his work cut out for him.
It's a little weird. We have tiles on the leeward side, so not on the side where we're going to.
Seeing a slight rotation.
Got right here, great. So the fact that we're seeing all these
the vehicle,
tiles still on the flap right now is really good, because that actually was one of our experiments where we wanted to test different connection methods on the way uphill on ship, so actually ascent. So it looks like most, if not all, the tiles are still hanging on there, so that's actually a really good data point.
Looks pretty good to me.
If you look just where
once again, this view is from the side of Starship, which is basically the second stage of the Starship vehicle as a whole.
If you look just above it, you can actually see the moon.
This is one of the flaps on the vehicle that helps to control its position and attitude as it is orbiting. And also helps to control during re-entry as well. That's a critical phase.
T plus 15 minutes.
I mentioned earlier that we're hoping to deploy those Starlink satellite simulators, as well as perform an in-space relight of a Raptor engine. If all of that goes well, we will be targeting a soft splashdown in the Indian Ocean. We heard from Suren on the recovery team a little bit earlier. They are standing by waiting to receive the ship that we see here.
The huge shield
All right, let's send it upstairs. Dan, how's it looking?
On ascent?
Hey guys, we are looking good. It does look like we are within bounds of what we analyzed if we were down one of our RVAC engines. So I wouldn't call it nominal orbital insertion, but
acceptable
we're
orbital insertion
on a trajectory that we had analyzed, and it's within bounds. So teams continuing to work through it with that engine out. They're working through some steps on the engines. We probably will end up skipping the Raptor relight for today, but it sounds like we should still be on for payload deploy, at least at this time. So very dynamic moments right here with the ship, but we do have it in space. It is on a trajectory now, headed towards the other side of the planet, and then a splashdown in the Indian Ocean.
Fortunate that unfortunately we won't have that
It's going to
Raptor
start
in
to get
Space Relay
darker.
demo,
We're
but
heading into an orbital sunset, so we're gonna have darkness for a little bit, and then it'll brighten up once we're on the other side of the planet, and hopefully looking at some good daylight when we re-enter into the Indian Ocean.
see some pressure regulation vents. Once again, you know, these are test flights. This is why they do these test flights. If this was NASA, this Starship would haven't even had launched yet. They do these test flights, launch it, see where things break. They've found where
All right,
certain
so we're a
things
little
break, and
over
they're gonna iterate
17
from
minutes
there.
into flight. If you're just now catching up with us,
For the next flight.
We did see a liftoff right at the top of our window. Super Heavy getting off the pad, initially lighting all 33 of those Raptor engines, got through a successful hot staging. Initially lit 6 engines on ship, had 1 RVAC go out on the way uphill, but still able to make it into space. And right now we're trying to see if we are going to get into payload deploy still.
The door's opening. I'm getting
Coming
ready
up
for
right on the
payload
part of the
deploy.
timeline when we were expecting it. You look inside a Starship there. Oh, I see a door opening.
The door has been opened for the
Looks like Hal didn't
largest
wait.
payload
Pez
ever
door
deployed
is
by
open.
Starship, mostly
Just a
Starlink
reminder, we've
simulators,
got
but nonetheless,
22
an
deployables
object
in the
that's being
payload
carried
bay
into
today.
space.
20 of those Starlink
It's
mass
not a normal
simulators,
projector
and
either,
then
but
2 are Dodger dogs, as we like to call them internally, sitting up their modified V2 Starlink satellites. Those are going to be testing a bunch of components that we're planning to fly on Starlink V3, and we've also got them outfitted with a number of cameras for another tech demo that we're trying out on this flight. We definitely are looking for a way that we can look at Starship's heat shield while it's still in space. You can kind of only see so much from the cameras and the flaps. You can't see everything kind of on the underbelly, and one of the only ways you can do that is if you got something else flying near it. So we're going to attempt to our final 2 satellites going out the door have a suite of cameras on them that are going to be looking back at the ship. We're going to be in nighttime, and so we've got, sounds like we're getting into payload deploy. We'll be in nighttime. They've got some powerful flashlights on them to try and illuminate the ship's heat shield while we fly away from it. So,
the payload deploy.
See some Pez motion.
And here we go, getting ready to deploy the first pair. They launch off in pairs. So pushes one forward, brings it back, then push out the second. You can see that the main batch, and here we go. You can see, coming out real quick, and you can see the first one coming out. It's now going to retract back in to send out the second. Never mind, it's just going to go straight out. Substantially more stable than on previous versions. Wow.
2 down, 20 to go.
And they're just continuing going here. See, it's happening substantially quicker
as a reminder
than on flight 10 and 11.
Graded in version 3 kind of gave a little soup up to the Pez dispenser, so those satellites going to move out a little bit quicker than they did on previous Starship flight tests.
Here we go. The second
first 2
pair.
out the door.
Stand by. There's the third. And here comes the fourth. Wow.
Flexing my basic math skills here today. Again, the majority of this stack, 20 of these 22 satellites, they're essentially just mass simulators, so they're roughly the same size as those Starlink V3 sats that we're hoping to fly later this year.
Alright, here comes the third pairing. And there it goes. Number 5.
Oh, and from this
You can see
top-down
those
view,
final
you're
two.
looking down at the stack.
And there's number 6
those
coming
two
out.
satellites you see on the very top. That
Oh yeah, those look like
they
proper
look very
Starlinks
different.
right
They've
there.
got solar arrays. They've got a bunch of other
Yeah, they're
deployables
solar
on
arrays.
them
I
that
mean,
we're
they
going to
have
be
their own
testing
power
out that are
generation.
going to be V3 tech, and they've got 3 engineering cameras and then 1 other camera that's hopefully going to be giving us some views of Starship in space. But we will see how that works. Again, this very much a tech demo. We're going to deploy those. The satellite's
22
going
minutes
to
into flight.
kind of try and turn everything on, look back at Starship, and
All right,
the
here comes the
primary
next set.
reason we're trying to do this is to get some
And
views
number
of the
7
heat shield.
coming out.
All right, 2 more out the door.
And here comes number
More
8.
out the door, and I think that counts, or that comes up to 8 total.
As you can tell, the teams are stoked to see this demonstration happening. It's pretty incredible to see this happening live from space. Now, as we noted earlier in the show, but worth repeating, this Starship version 3 is built to deploy up to 60 of Starlink's more advanced V3 satellites. Everything's V3. Designed to offer 60 terabits per second of downlink capacity per satellite. Now that is 20 times more than each Falcon 9 does today.
There's number
Incredible.
9.
All right, I think that's number 10 going out the door.
And there's number 10.
Yeah, there it goes. So yeah, the camera view you have on your left screen there is basically right at the bottom of the payload volume.
You can actually see the top of the methane
kind of
tank.
dome-shaped structure you see there is that's actually the top of the fuel tank.
Yeah.
Then the camera view that you have on the right is an external camera that we have positioned so that you can see basically the light through the open Pez dispenser door that you see. That's that sliver of light. We can see the Starlinks
And here comes number 11.
deploying as each one comes through.
Right. And there goes number 12.
As we mentioned, we have 20 of these Starlink simulator satellites, and then we have 2 of these specially modified, as we call them, Dodger dogs here around here. Those, as Dan mentioned earlier, they have some V3 tech on them, some solar arrays, and those will be the last 2 that will be deployed today.
Yeah, that's right. And seeing this, as I think Dan called them turbocharged or supercharged Pez dispenser, it's definitely coming out much faster than our previous flights. So that is really good to see. Yeah, look at that.
There's number 13.
And especially once we, fill Starship up all the way with around 60 or so of these Starlinks,
And there's number
being able
14.
to deploy them fairly expediently, is going to be important for designing the overall mission profile.
Yeah.
25 minutes into flight now.
Now, fans of
You
Starship
can see those 2 Dodger
may know that
dogs.
Starlink enables lots of
look
unprecedented
substantially
views,
bigger
both from space, as
than
we
the
see
other
here,
ones, and also they
on Earth.
see
In
radiators
addition
on
to
them
the
and
dozens
just
of cameras on
they're just all
Starship
kitted
itself,
out.
we also have mobile Starlink camera kits deployed
Most
in the
likely
Indian Ocean.
taking the opportunity to also test
Yeah,
some hardware
Starlink
that
also
wouldn't need to be
connects
used if it
our
was just
aerial
scanning the heat
cinematography
shield.
units on the ground at Starbase and
We're just
at
testing
other
some V3
strategic
systems
camera
in
spots
space.
around Texas.
It's all part
go.
of
Here comes
how
number
it all
15.
comes together to tell the incredible story of Starship both on and off planet.
Yep.
Number 16.
All right, we're getting low on the stack. It looks like we got 2 more of those simulators to go out, and then it will be time for our Dodger Dogs, those modified Starlink satellites. Just a couple of updates while we continue
26
to
minutes.
watch payload deploy. Did get confirmation we're going to be skipping that relight of the Raptor engine, just due to everything that we saw on the way uphill.
That's fair.
Those sea level engines, we're going to use them for a landing burn, though. They are still capable to be used for that. So we'll still look to do a controlled landing in the Gulf.
There's number 18 coming out. Or I'm sorry, no, that's number 17 actually. Unfortunate to
I
hear
think
that
that's
news, but
19 and 20 headed out the door.
oh, okay, I completely stepped counting. And the final two, the two Dodger
So
dogs.
these are modified V2 Starlink
Here we go.
satellites. We
And
do
see they're all
have
kitted out.
a number of
Probably
cameras
taking
on
the
these that are
opportunity
going
to
to
test
attempt
out
to look
some
back at Starship.
V3
We're not going to get
things.
this video in real time, but we're going to try and turn it around if we do get some video down. So we don't worry, if we get views of Starship from these satellites, we will be sharing.
All right, great to hear.
And these will be exciting because again,
Or,
they're
I'm sorry,
really a
that's
tech
19
demo.
and 20.
Getting our chance to test out some of the technologies for version 3.
Okay, let's count it correctly.
All right, I think that's
Wow.
18 and 20. My basic math skills are failing now. All right, here we go.
Now time for the two Dodger dogs. Placing and lifting up the thrust structure. I just secured them down.
We're standing by for Starship, basically to serve the
Slow.
first Dodger dogs to low Earth orbit.
And they're coming out now. Number 21.
And one out the door.
Rolling back, getting ready for number 22. Well, rolling
In
back,
this
not
view,
the full
you can
way.
kind of see on the right side of the satellite, you see some bright white spots. Those are our flashlights. Beneath them,
Oh,
the
yeah.
camera's going to attempt to look back and image Starship's heat shield
I believe that they're going to
as
space
it
them out more
flies
to make
slowly
sure
away from
that
the
they
vehicle.
get the most amount of views. And there's
There
number
it
22,
goes.
the final simulator on this. Oh, you can see the flashlight very bright now. The ship is now going to rotate,
there be light.
roll 180 degrees. You can see that roll happening right
like
now.
the light is just shining right at us there.
Wow.
If you couldn't tell, we're pretty excited.
Yeah.
It is always sunny in space.
Always sunny in space, and that
Vehicle
looks like an
continuing to
empty
rotate
payload
over.
bay. So
Sure does.
that's exactly what you want to see there. That's great.
The payload bay door
So yeah, with
closing
payload
now.
deploy complete.
full
You can see the
deploy.
door closing there. All right, there we go. So yeah, with payload deploy
29
complete,
minutes and 10
Starship will
seconds into
now
flight.
close its
Wow.
Yeah, Starship, we closed the payload door, and we're going to continue to coast around Earth all the way to the Indian Ocean. So still a lot of major events to come today. Sounds like we're not going to hit that Raptor relight, based on what Dan was saying, but after that, of course, we'll have the atmospheric reentry and splashdown. And with that, we're going to go on another quick coast.
So sit tight, enjoy some amazing space views and the space jams, of course. And we'll be back in a few minutes for Raptor relight, or excuse me, not for the relight, but we'll be standing by for atmospheric reentry.
Yeah, they may also have their own propulsion systems. Wow. Those Starlink simulators just taking the time to also test out some things for version 3 of the Starlink satellite. Then we're in this little intermission phase. Yeah, a few things I couldn't help but notice is that also on boost back, when the booster was rotating over, there was a slight wobble on the Super Heavy. When you looked at views from the ship, you can see those Starlink simulators right now. As the vehicle rotates over, getting ready for the scan of its heat shield. Wow. Yeah, so we're currently in orbital nighttime at this moment. Folding the flap. Just testing out the flaps. Yeah, both the aft forward flap. So at T plus 47 minutes and 47 seconds of atmospheric entry. I'm gonna test out all the systems, but first we're really excited to get these shots. We're gonna see Starship floating, vacuum of space, in the third person view for the very first time. Very exciting. We'll continue its rotation. I really hope that during this stream they'll show us views from the Starlink simulators. Because I guarantee you, as it flew out, the camera's also recording. So I really hope they'll like release a full video of it coming out and then seeing the Starship roll 180 degrees on its axis. Starship currently doing that roll. Do a tracking shot. Starship. It's floating, flying over the Atlantic Ocean now. Gonna cross over the southern area of Africa before splashing down in the Indian Ocean in about 33 minutes. we're getting a shot of those Dodger dogs coming out. Wow. I'm speechless. That's insane. For the first time, from a third-person view, we can see Starship floating in the vacuum of space. See still cryogenic propellant. Watching as that payload bay door closes. The SpaceX insignia. And the
All right,
top
so
section of the ship.
surprise. Looks like our cameras did work. We've made contact with both of those satellites. We're going to roll that back again.
Wow.
Again, this is a view from one of those satellites as we deployed. It looks like this was from the last one out. Flashlight turning on, taking a look at Starship in space.
Wow.
The way this system is set up is the satellites are essentially recording it, then making contact with our...
You can still see a bit of the cryogenic propellants in the vehicle. Obviously, it's just the top section, but... And the captures.
Our test to try and develop a free flyer
Wow.
that we could fire outside of Starship's payload bay, look back at it, and then do essentially a pirouette with Starship to get a look at the heat shield, where it's going to be really important when we start bringing these things back for a catch.
Absolutely speechless.
Which
That's
we
insane.
are hopefully doing in the not too distant future, as they are intended to be fully reusable. But this will give us an opportunity to look at the heat shield while Starship is still in space. So there was a glimpse. We'll see if we get any more video down from those satellites, but I mean, that's one we've been chasing for a while, so really cool to see it come to fruition here on Flight 12. All right, coming up on 40 minutes into the flight.
Obviously, the
and
vehicle
we should start
rolled over,
hitting
so I'm really hoping
the reentry period in the next 7 minutes or so.
Yeah, I'm
You'll
really hoping
start
that
to
they'll
see
at
a
some
light
point
show
release
building
the full
up.
video of it.
As we had
You
talked
can see
about,
the
we
ship
did skip that
rotating over
on-orbit relight
and
of the
rolling
Raptor engine. It was not
and getting
needed.
an image of those.
For our trajectory or anything,
Those
we
heat
are on
shield
this
tiles.
suborbital trajectory to splash down in the Indian Ocean. We are
But just such a
going
beautiful
to attempt a landing burn.
of
We'll see
Starship.
how they perform when we get there. And just a reminder, we are going to be stressing the ship on the way in. We're going to intentionally do a maneuver where we're going to kind of pitch the nose up and deploy those bottom flaps to really put a lot of pressure on them. So we'll see how it does through that maneuver, and then we'll be doing kind of a final banking
Almost like
turn
pitching the
before
vehicle
we
over
get to a
extremely
landing
rapidly,
burn.
then
So
stopping it.
all that coming up
And
in a
then
few
rotating it
minutes.
back and then just
The
doing
light
that
show
repeatedly to
should
really
start
stress out
beginning
those
real
hot
soon.
flaps. Here's the ship is at a nominal attitude for entry. After the Dodger Dogs observed the heat shield, it rotated back over for entry interface. So yeah, once again, I really hope they release that video. I'm sure that they will. Yeah, I'm thinking we'll have a little post show where we, I'd love to take another look at that ascent. And I just want to see, like, just how extreme the oscillations on the booster were. I just remember seeing oscillations, but I never actually, like, measured, like, how many degrees per second does that look like. 4 minutes 20 seconds. In 4 minutes, we have the expected time of entry interface. This might be slightly weird because the trajectory is ever so slightly off due to losing an RVAC on ascent. So it might slightly shift, but most likely be extremely similar launch point. Oh, these are very interesting. Yeah, like my first guess on what that is would be like insane, but have to see. I'll look more into why those appear. Crossing through 100 kilometers, so the ship is now no longer in space, and at 85, even though it's not experiencing extreme heating yet, it's now technically no longer in space. But yeah, at 85 kilometers, the flaps, well, that's at least with version 1 and 2. At 85 kilometers, the flaps took control of the vehicle. The flaps are the same size as on version 2, so they'll have about the same control authority. Actually, due to the ship being slightly lighter, most likely more. Yeah, because after it burns off almost all of its propellants, which it has now, it's lighter than V2 was at the same stage, because its dry mass is just less. So, we might see flaps take control of the vehicle slightly above 85 kilometers, but we'll just have to wait for the call out of when that happens. You can see some plasma starting to form around the vehicle. About 47 seconds to expected entry interface. Oh, you can see slight vent from the RCS thrusters. We passed through 85 kilometers. This camera is actually mounted onto the flap, so you can tell if the flap's moving by wow. If the camera's moving, the flap's moving. You can see the colors of re-entry heating starting to form around the ship as it's moving its flaps. The flaps now taking control of the vehicle and guiding it to its targeted splashdown point. This is where the heating starts to get pretty extreme as we cross through entry interface. This is the least they've tampered with the heat shield. This is the most complete heat shield that they've flown to a re-entry, so we're very excited to see how this ship will hold up. Really hoping that those Raptor 3s will successfully light, and perform a great landing
Welcome
burn.
back to Starship Flight 12, the first test flight of Starship version 3. As Dan mentioned earlier, we were able to make contact with the modified satellites just shortly after deployment. And as you may have seen, we got some sweet views of those sats looking back at the ship. Pretty cool to see.
Yeah, those views were incredible.
Now, as you see on your screen, currently the ship is re-entering the Earth's atmosphere. This is the plasma starting to build up on the exterior of the vehicle. Now, we do not plan to recover the spacecraft today, but rapid and reliable reusability is the ultimate goal.
Yeah, that's right. And re-entry is a critical phase of flight, and we need information on how the ship's systems perform. Re-entry is an extremely demanding portion of flight where we essentially have to scrub all of the energy we use to launch the rocket back off in reverse. So the 18 million pounds of thrust that we had off 33 of those Raptor engines.
Just a little.
Just a little. We're now, and then another, several minute burn on the ship. We're now basically undoing all that energy here via aerodynamic braking, essentially.
Oh yeah, you can really see.
And of course, Starlink is a big part of it, as that's what allows us to actually gather this data and show these live views.
Negative pressure zones. Forming.
And again, the data gathering is really the main reason why we're doing these flight tests.
Shape of Starship.
So Starlink provides us just one more path to collect that data that ultimately allows us to rapidly iterate Starship's design.
Now, if ship manages to make it all the way through re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere at these hypersonic speeds, which is basically more than 5 times the speed of sound. Now, we do anticipate that it might be a little bit of a spicy re-entry, so we'll see how far we get. Re-entry is typically a portion of flight where we don't have communications with the spacecraft because it's re-entering at or around orbital velocity, roughly 8 kilometers per second, or for those of us that think in other units, roughly 5 miles per second. At those speeds, the spacecraft is moving through the atmosphere, and it creates that plasma field that we saw forming around the vehicle.
Yeah, and although the plasma looks really cool, it does distort some communication frequencies. So it's not uncommon to experience brief blackouts in communication.
Of the plasma forming around the vehicle.
Of course, thinking long-term here, Starship is designed to land on Mars where there are no runways or other humans to help out. That's why we're going with the propulsive landing instead of a more traditional means like parachutes. Propulsive landing, not only, again, is it more cool, but it enables a more rapidly reusable rocket.
Yeah. Now, we should hear some call-outs as the ship makes its way back to Earth. When we hear entry max heating and entry max Q, that means the ship has made it through the maximum heating and aerodynamic loads that it will experience as it returns. So if we make it through those, we're doing pretty well.
Yeah. And you can see in the bottom left right now, we're at 23,500 kilometers per hour speed. That's just a crazy number to think about. But as we keep progressing the mission, we are going to hear a call out when the ship is transonic and then subsonic. So transonic refers to the period are concurrently below, at, and above the speed of sound, kind of in that Mach 0.8 to mostly fly around Mach 0.74 to Mach 0.85. And after we hear the call out that Starship is transonic, we should hear the call out when Starship is subsonic. This refers to speeds that are much less than the speed of sound, so at this point in the flight, ship's velocity will be slowing down.
We definitely have a crowd still here in the lobby of SpaceX headquarters down here at Starbase, Texas. Everyone is, loves watching ship re-entry. It's always such amazing colors. This must be what it feels like to be one of those praying mantis shrimp or mantis shrimp. Can't remember exactly what the name is, but the ones that see in billions of colors. This is the closest I feel to being one of those.
Yep. I think one other thing that's cool to point out right now is look in the bottom right. You can see where we are on a globe there. We're squarely in the Indian Ocean already, and we've only been flying for 53 minutes.
Yeah.
So pretty crazy. We went all the way from Texas to the Indian Ocean in less than an hour.
Yeah. She flies pretty fast.
She
that
flies
is for
very
sure.
fast.
All right, so the light show continuing. We are through the period of peak heating, and we'll
Cross
be
through
looking
peak
at
heating.
the peak pressure coming up in the next couple of minutes. The
And
next
we're
10
about to
minutes
approach that peak
are
pressure
probably going to
regime.
be the spiciest of entry today. As a reminder, we are going to be doing some stress work on this ship, where we're going to do a maneuver where we kind of kick the nose up to fully
ready
deploy
now,
those
we're-
aft flaps. To really
So
get
temperatures actually get
a
slowly
good
lowered down
test
now.
of the structural strength of that part of the ship. We
But
did that
the
on one
structure
previous
is
flight
about
test on version 2.
receive
We're going to try and do
its
that
ultimate
today.
test
Since we did skip
of this
the
re-entry
in-space
as we
burn, we're
cross
carrying
through
a little bit of
block
extra propellant in our header tanks up in the nose. And so that's going to put a little bit of extra stress on those forward flaps as we come in. So we will see if they're able to hold through that re-entry. So that will be another watch item. We did skip that in-space burn, but we are expecting at least 2 of those sea level engines to try and ignite for a landing burn. We entered the entry period in a good attitude, so hopefully making our way to the targeted splashdown point. We've got that Starship recovery team standing by, and we should be about 10 minutes away from splashdown. So a lot of excitement over the next couple of minutes. Kate and Jake, let's see how Starship holds up on the way in.
Yeah, and we just heard on the nets there that engine chill has started. So essentially what that means is we are prepping the landing engines by getting them down to temperature ahead of that landing burn later in the mission here.
Just ensuring that the thermal shock doesn't crack the lines.
And on a lot of our previous flight tests,
thing
we've
to
been
hear.
removing a bunch of the tiles. If you've watched those, we were really intentionally trying to push ship beyond its limits. On the
Well,
last
getting brighter
flight, we
now.
even had basically a hole get punched into the liquid oxygen tank that you could see when we did the landing burn into the ocean, and this ship was still able to make it. But right now, we're really going to be testing the structural strength of these flaps on the way in. Again, this is a flight test. We're trying to intentionally find where our limits are. And in this view, you're looking at a whole bunch of tiles. I think Jake talked about it earlier. We bonded some additional tiles to the leeward, or kind of the metal side of Starship, to see how those different bonding techniques would hold up. And looking like we've got quite a bit still attached.
Thanks to hear.
Yeah, and as we're going down through the atmosphere here, we are at about Mach 16.1. So still extremely fast, although we have, scrubbed off a substantial amount of our speed already. Altitude at a little less than 60 kilometers.
Oh wow, you can really see the heat. Those flashes of light are normal. It's just oh shit. What I really find
All right,
interesting
we're
is you can
about
see
8
that,
minutes
like,
away
blue
from
glow
our targeted landing
that
and
catch
splashdown
fin
time.
up at
Again,
the
this
top,
is
not
when
to
the
be a
ship's
screen.
going to
Oh.
start
The
really
ship
getting
is
put
approaching
through
the
the ringer.
end of the peak heating region.
Just heard the call out, getting to the
heating.
end of the peak heating. So
Alright.
the
Crossing through
the highest
that-
temperature the Starship's
crossing
going to
through peak
see
heating
during its
here.
re-entry.
Flaps guiding the vehicle.
This camera angle changes as it is attached to the forward flap on Starship. So we're actually experiencing the articulation of that hardware, helping to steer the ship down for its precise landing in the Indian Ocean.
Velocity being scrubbed off extremely
Yep, that is
quickly.
just a really
1.2
cool,
Gs.
kind of cool piece of perspective there.
56
I
kilometers.
know some people say it makes them a little feel like you're really riding along with the ship on the way down.
Yeah, and aside from just looking cool, ship, so
Ship has passed through the peak heating region. External temperatures are coming down.
Great
Wow,
call
that is
out there
incredible
through the peak
news.
heating region.
As Dan mentioned, we were expecting this reentry to be super spicy, but excellent news that we're now past that period of peak heating and that now the external temperatures are starting to decrease. Those heat shield tiles there on the belly of the ship really doing a ton of work to burn off all of that inertia that the vehicle had
T+1 hour
prior to re-entering the atmosphere.
Yeah, and you can tell by the G meter down on the bottom right that
1.8
we're starting to pick up
Gs.
a couple more Gs here, so we're definitely entering the thicker part of the atmosphere where we're scrubbing off all that energy, like Kate's saying.
45.5 kilometers. Passing through 11,300.
all right, just about 5 minutes or so to go.
Now
We're coming up
11,000.
shortly on the maneuver where we're gonna. It's
Clouds are
affectionately
starting
called the flap slap, where we're
dim
going to
down
kind of
just due
pitch
to
the
the sun
nose up
hitting
on
it.
the
It's
ship, and you're going to see those aft flaps, the
also
ones on the
just
very bottom,
dipping
fully
down.
deploy.
Now we're getting ready for that stress test. 2 Gs now.
Ship is at peak dynamic pressure.
Peak dynamic pressure on the vehicle. And Gs are
And
now
we're
letting
now
down
at peak pressure.
and increasing. And we have the stress test. All right.
Ship flap load test has started.
And here we go. Really stressing out those aft flaps. 2.1 Gs.
Looks like it's holding. Again,
Flaps
the intent of that
tanking
was
it.
to put just a lot of extra stress on those aft flaps. We are expecting the forward ones too to see a little bit of extra stress as we've got a little more propellant in our header tank, so the area right at the very nose of
Ship
Starship
flap load
that kind
test
of
is complete.
And that's a good
hammered
flap
through that
load
test.
test and successfully
There we go.
completed.
And we just did that test at Mach 7, just for reference there. So we are still going incredibly
The ship doesn't look
fast.
like it's ever even been touched before. That's how well it's holding up. So looking absolutely amazing.
All right, we are just about 3.5 minutes or so away from our targeted landing burn. Again, we're expecting to try and see 2 of these Raptor engines light for the landing burn. Normally we plan for 3, but we're going to give it a try with 2.
Again, ready for the dynamic banking maneuver.
Hopefully we've got
Ship is
Seren.
starting the RTLS banking maneuver.
And there's a call out for it. The
And that right
vehicle's now
there,
gonna
so we're
yaw
starting
over.
a banking maneuver, and essentially what that is when we come back to Starbase, or when we plan to come back to Starbase, the trajectory is designed so we'll essentially swing out over the Gulf and do a swoop maneuver to then come back to the towers for catch. And so we are doing that exact same maneuver as we head towards our targeted splashdown in the Indian Ocean.
The vehicle now
Yeah, and that
rotating
call
over,
out there that
guiding
we
itself
heard,
to its
RTLS
splashdown
stands for
location.
Return to Launch Site. So definitely a
Well,
pretty
you can
cool
see
thing we're
that yaw
demoing here on the
happening right
ship.
now.
You know, as in the future, we are going to be trying to bring the ship back to the launch site, which is
Yeah.
going to be absolutely insane.
Absolutely. But of course, we want to test out these maneuvers, these principles prior to actually bringing the hardware back to the pad. This is the same reason why we were, intentionally not trying to bring the booster back to the pad. So we're trying all these things out in this developmental phase of the vehicle, and really proving what a test flight is.
Absolutely.
Dynamic pressure is coming down.
Dynamic pressure coming down.
All right, we heard there, dynamic pressure coming down, and I'd say we're in a pretty good bank right now.
Yeah, executing the power slide.
Coming down as it
We're
yaws
about
back
90
over to
seconds
regular.
away from our
Most likely
anticipated
gonna yaw
landing
in the
burn.
opposite direction.
Clouds coming up, pretty sunrise on the other side of the planet.
Starship is subsonic and is on target.
Subsonic and on target, amazing call out.
The crowd here reacting to that call out, letting us know that we are on target for this precise landing
Crossing
in the
through
Indian Ocean. This
700
will once again be a soft splashdown.
750 kilometers an hour.
We should get some pretty cool views from the
15 kilometers
recovery
in
team who we
altitude.
chatted with earlier.
And Starship
They are
has now
standing by
entered
to
that belly
receive
flop
this ship. Once again, this
Getting
is
ready
the first flight of
for
our
its landing
completely
burn.
redesigned Starship version 3.
Yeah, and if you
Really
remember
hoping
the
that those
suborbital
engines light.
flights from a few years ago, this is very much the same regime that we're in here. So we're sub 15 kilometers, executing what we call the belly flip maneuver.
Yes, serial number 8, the first.
10 kilometers. Speed still coming down. Getting close to its terminal velocity at this altitude. Seven kilometers. 500 kilometers an hour. You can see those flaps moving. And there's that turn that I was talking about for that final approach, the 180-degree turn, simulating as if
Yeah, Starship
it was
doesn't fly like an airplane. It's
coming
a
in
lot
for a
more like a
catch.
skydiver. Full belly
we're
flop
getting
on the
ready.
way
Here
down, using those
comes
flaps
that
similar to
landing burn.
arms to help change the path of the air over you. Coming up real soon.
2.2 kilometers.
Again, going for a landing
2
burn,
kilometers now,
trying to
400
light two of
400
these Raptor
kilometers an hour.
sea-level engines.
Passing through the clouds.
Landing burn startup.
Landing burn startup. Here's
Landing
that call
burn
out.
startup.
2 of the 3. Whoa!
2 engine flip.
There's that flip. Vehicle's now rotating over.
Successful flip.
Correcting. And landing.
Buoy
Version
cam
3
check.
has landed.
Good shutdown.
A great landing burn shutdown, an amazing landing burn, an amazing shot. Whoa! The explosion as it hits the water. Wow.
Amazing.
What a test flight. It made it all the way down, even with 2 engines, still successfully completed its landing burn.
As weird as it may sound to hear, but it is the truth.
Absolutely wild. We,
And
at the beginning
what
of the show,
a flight.
we guaranteed excitement at the beginning of the show, and I'd say Starship delivered.
Absolutely. An incredible day for Starship. That was the first flight of that completely redesigned vehicle. As you can tell, the teams are incredibly proud
Wow.
of what we just saw.
Yeah, V3 definitely showed up. That was amazing.
Yeah.
Yeah, we've pretty happy crowd in the control room behind me, I will say. It's probably the most excited I've seen a lot of people in a really long time. On target landing.
What
Wow.
a landing.
Actually, let's jump over. Hey Tyler, how's everyone holding up in Hawthorne?
We're having a great time, Dan. Thank you so much. That was another
What a
exciting
landing.
Starship flight in the books, and we hope that you enjoyed those
And
awesome Starlink views. So congratulations to the team at Starbase and everyone here and around the company. So many employees have contributed to the Starship program as we continue to iterate and make progress towards a multi-planetary future. So that wraps it up for us here in Hawthorne. Thank you guys for tuning in. And back to you, Dan.
All right, thanks. So just to recap, we lifted off right at the top of our window, 5:30 p.m. Central Time. We were able to see the booster light 33 of those Raptor engines get off the pad and ascent over the Gulf. Successful hot stage separation. Initially lit 6 of those Raptor engines, lost one of the RVACs on the way uphill, and then the booster didn't complete its full boost back. Its mission ended a little bit early, but landed in the clear area that we had set in advance. Once we were on orbit with ship, we were able to get through our payload deployment, 22 satellites, the 20 simulators, the 2 Dodger dogs, which successfully turned on cameras. We'll see if we got any more views from those. So obviously stick around. Skipped the Raptor relight, but made it through re-entry on target landing in the Indian Ocean. You saw those views. Starship made it. It's been a long time coming. We're really excited to see this vehicle fly, and there are several more on the way. So that's going to do it for me up here. Send it back down to Kate and Jake and everybody who I hope is at least a little bit excited down in Star Factory.
Oh yeah, it is absolutely
Wow.
insane down here. We would, of course, want to thank the fine people of Cameron County, including the residents here at Starbase, as well as the Coast Guard, the Federal Aviation Administration, the Government of Mexico, and of course the Australian Space Agency.
Yeah, so honestly, just huge congratulations to all our teammates here at SpaceX and everyone who's supported the Starship mission just in general here. It's been a massive effort, really incredible.
Yeah, there's a lot of people that worked really hard to make things look easy, so shout out to those teams. Now be sure to follow SpaceX on X for updates and more exciting views that we didn't get to show you on today's live program. I have a feeling we'll see some pretty amazing stuff come from those demonstration satellites that we were able to show some initial footage of. Now, if you're interested in more launch coverage, head on over to our profile on X. We also have spacex.com/launches for you to check out for the most up-to-date information. So thanks to all of you for tuning in. We're going to close it out and celebrate with our colleagues. Thank you so much for tuning in, and have a great night. We'll see you next time.
Oh, and is this me full view? What a beautiful image. SpaceX Starship. You can see thrusters firing slowly, rolling the vehicle. Okay, and it didn't reset the capture. So that's annoying. Hopefully, they will release more views of that when it becomes available. Yeah. I'm looking a bit more. Video. I really want to take another look at that hot staging.
So we're going to stand by for that. We can see the flaps.
Maximum dynamic pressure.
Yeah.
Over a minute into
really
flight now.
At this, actually.
Vibrations chilling out here at Star Factory as we continue to watch Starship Flight 12.
One sec.
Reminder, we do what's our version of MECO. Most engines cut off, so we're going to shut down all but
Okay. Yeah, so it drops down to the nominal 5, which was expected. Then we had stage separation. And as it tried to ignite, yeah, like serious oscillations on the vehicle. It ignites a lot of the 13, but then a lot of them just shut down. And then the boost back burner is just shut down early just because. If you can't control where a rocket engine is pointing, you really shouldn't be firing that rocket engine. So just out of an abundance of caution there, it just stopped it. But what I find extremely impressive is how it was still able to recover from that roll. So it comes down. That's very interesting. You can see how the Raptor engine nozzles are like vibrating as it's coming in. Vehicle continue to come in. Yeah, here those vibrations is oh come on. It didn't show any of that. Okay.
Got off the pad or the whole stack. That was quite incredible.
Yeah, so like as it
Absolutely. So
crosses
we
through
have
10
views here from the
kilometers, it
booster
actually
coming
stabilizes
back
the roll,
down,
which I find very
making its
interesting.
way into the Gulf.
Sorry, it's very impressive
Pretty
with the
cool to
GNC.
We have
see.
healthy chamber pressures on 5 out of 6 Shape Raptor engines.
Great news there
Landing
for
startup.
Starship.
And you can see the vapor cone, and then immediately a fire, and then it shuts down.
Once again, we
Majority
were
of the
not
engines
going to bring the
as
super heavy
the
booster
ship
back
slams
to the
into the
tower.
water.
We were planning on having it land in the Gulf.
But yeah, that's.
And it looks like the booster ended its mission there.
Yeah, like it's probably gonna do it for today. I might stream Flight 13. There was just a bunch of issues with today on how my computers kept on cutting out, so maybe. Yeah, like there's just a bunch of technical issues, like there were a lot more details that I wanted to talk about, but I just wasn't able to because we ran out of time, because like just technical issues. So, like if I'm doing another stream, like I'm only gonna do it if I'm certain that it's gonna be higher quality than the one today and also yesterday. So yeah, I'll think about it, but it was an amazing flight today. You know, got through almost every objective. I'm really curious to see how this handled because an FCC license said that on Flight 13 they could go orbital with the ship. So I'm really curious because what real what everyone was thinking about was this would be determined by the booster is going to get everything done and it's going to go great. But it's like, how's the ship going to do? But the ship did everything it was supposed to do. Actually, they probably won't go orbital on Flight 13 because they weren't able to do that Raptor relay demo. If they could, maybe, but just because they weren't able to, they haven't demonstrated that they have the capability to deorbit the ship. Starship is the biggest single object ever sent to space. So if you can't deorbit that, you have a 52-meter tall, just 100-ton object coming in, and it's gonna re-enter uncontrolled, and with that, and like with those heat tiles, a lot of it would probably survive and just cause some serious damage. So, we'll see. But yeah. So yeah, might stream Flight 13. Might not. I'll have to see. But yeah, it was a great stream today. Everyone that joined in, I really appreciate it. So yeah, we'll see you guys next time.